we forget which one is X and which one is Y, let's think about which of these numbers depends on the other number. It makes sense the way that we put it because how tall you are depends on how old you are, for the most part. Obviously, we're going to have some outliers with something like this. There's some people who are in their 30s and 5 feet tall. There's some people who are 13 and 6'2", right? So there's extreme cases on both ends of the spectrum, but we can logically say that it makes sense that the older you get, the taller you are, right? It wouldn't make sense logically for us to say the older you get, the shorter you get, right? You don't shrink as you get older, you grow. Does that make sense? Okay. So take a moment. My y-axis is height in inches. My x-axis is age in years. Go ahead and plot these 5 points on this graph. My first point's going to be at 6,45, which is right there. And you can take the rest. Good, Jaron. Looks great. Perfect, team. Good, Delaren. Perfect. Good job. Great job. Good. Perfect. Perfect. Nelly Sophia looks great. Yes, sir. Good. Not too bad, right? So my second point, 8,50 is going to be right there. My third point, 10,55 is right there. And for the most part, so far, this looks linear. But then we get 12,61. So there's 12. I go up. There's 60. 61 is just going to be a little bit further than that. Now, it's going to be in between the grade here, but that's fine. And then we've got 14,63. Again, it's going to be kind of in between, just like that. So between the ages of 6 and 12, if we wanted to just analyze this graph for a second, between the ages of 6 and 12, Bob is getting taller at a pretty steady rate. Right? He's growing like 5 inches every 2 years, so 2.5 inches a year. But then between 12 and 14, that rate gets a lot slower. Right? He only grew 2 inches in 2 years, as opposed to 5 inches in 2 years. And this happens a lot. Right? You hit a certain point, and your height just starts to, it's called plateau, which means it kind of, the graph flattens out if we were to plot it. Right? I've been this height for the last, 8 or 9 years. I just stopped growing, and eventually you all will stop growing as well. But every one of you is probably still growing in height right now. But if you were to plot kind of my height, right, you don't have to do this. We would see that I'm getting taller and taller, and then eventually I kind of just start to flatten out. And that's normal. Anyway, let's describe the association between Bob's age and his height. What it means by describe the association is, do we have a positive association, a negative association, or no association at all? If we take a look back at our notes, what type of association does this look like here, Devin? Positive association. How can we tell this is a positive association?
Because it goes like up, like it keeps going up and up.
Good. As we move on the graph, we're going up. What we can say that's to take that a little bit step further, as Bob's age increases, his height increases as well. If we look back at our notes, our little kind of like definition of positive association was as the independent variable, which in this case is age, increases, the dependent variable, height, increases as well. So we could tell this is a positively associated scatter plot because as his age increases, his height increases as well. Give me a little thumbs up if that kind of logically makes sense. You follow it, understand it. Good, like I said, this lesson's not about solving anything, it's about understanding things. The more we understand about this work, the easier our project is going to be we'll probably get it on Thursday. The project? Yeah. Take a look at number 3, a different example here. We're talking about basketball shooting. Okay. So this scatter plot shows the basketball shooting results for 14 different players. Describe any clusters you see in the scatter plot and identify any outliers. So we took a look at association in numbers 1 and 2. Now we're going to take a look at some clusters and outliers. So let's examine the graph first. Anybody in here play basketball or a fan of basketball? 1, 2, 3, 4. Only 4. That's okay if you're not a fan or if you don't play basketball. Do you kind of understand how basketball works in the most basic sense? Okay, more hands. That's good. If you don't, you throw the ball into the basket.
Yes.
That's how it works, right? So if we're keeping track of basketball shooting, each one of these dots represents a player on the team. My x-axis is the number of shots attempted. And my y-axis here is the number of shots made, or shots that went into the basket. So if we want to look, right, this little point here, if we want to focus on this point for a second, is someone who shot the ball like 9 times and made about 4 of the baskets, right? We could fill in our axis here if we need to, just to make it easier on our eyes. Someone up here, like on this point, shot the ball like 23 times and made about 14 of those baskets. So they went 14 for 23. Someone all the way down here, looks like they went about 2 for 8. Which is not great. 25%. So that's kind of how we can understand what each of these points represent. How many times did this person shoot the ball? 35 times. About how many baskets did they make? 16, 17, right? Somewhere around there. We're definitely above 15. This might even be like 18 because it's kind of past the halfway mark. But yeah, 17, 18, around there is fine. So 17, 18 out of 35. So with our highlighters real quick, hopefully we still have those out. I want you to circle up a cluster that you see. I see a very clear cluster here. I want to see what you guys think. Go ahead and highlight that little cluster of points. Perfect, Nelly. Good. Great, Tina. You got it. You got it. Perfect. Some of us see 2 clusters, which is even better. I see one that's definitely much more densely populated, and that's this cluster right here. All those points close together, kind of overlapping one another. And let's figure out kind of where that range of points falls. It looks like we're going from maybe like 18 shots attempted to 24 shots attempted. So 18 to 24 shots attempted. and they made like about between 8 and 15. You always want to do y over x, right? Morning.
Delirium here?
Yeah. There's everything in the front. Go ahead, Delirium. So we see a cluster here. We could say that this cluster is around kind of like 20, 10. Cluster around 20, 10. Good morning, Michaela. Okay, perfect. It's right over there, I think. So this cluster here tells us that a lot of people on this basketball team, or at least a significant number of people on this team, shot 20 times and made 10 of those shots. In general, some shot less and made less, some shot more and made more, and all in between. But in general, we could say that this cluster represents the players that shot 20 times and made 10 of those baskets. What percentage of made baskets would that be? 10 out of 20?
Yeah.
What would that be as a percentage?
50. I would say like 50.
Thank you, Osasa. You got it. 50%
It's okay.
made baskets, which may not seem great, right? You're like, well, you're missing half the time. But 50% from the field, especially when you're shooting 20 shots, is actually really impressive. Put me on the court, I'll go 5 for 20. Actually, probably 2 for 20. You're shooting 10%. So that's where our cluster's at. That's one way that we could describe this cluster. Is there any outliers that you see here?
Yeah.
Go ahead and highlight that outlier for me. I see a very clear outlier. But I want you to find it first. I think we already talked about the outlier.
Yeah.
There it is. It's around, I'm going to say 35, 18. So while most of our players on the team shot around 20 baskets, this individual shot 35 shots. 35 shots, and they made about 18 of them. If we wanted to find their percentage for shooting, 18 divided by 35, look at that. It's right around 50%. Now you think, well, isn't this an outlier? Isn't it supposed to kind of be outside of our normal range? Well, take a look. If we drew a line straight through this scatter plot, this point actually kind of tracks. What I mean by that is it falls in line with the rest of our points. And we found that in that cluster, those players were shooting about 50%. So it makes sense that this point, even though it's far away from our data, still falls in line with around 50%. It just so happens that this person took almost twice as many shots as the others, but they also made almost twice as many shots as the others. So we could say 50% made baskets, and then outlier at 35, 18 is a player who took way more shots. We're running out of room, I know. But it had a similar shooting percentage. And I don't like this last question, number 4. Explain how you can make a scatter plot from a set of bivariate data. We don't even need that term, is annoying. We can cross that out. How can you make a scatter plot from a set of data? That's why I don't like that question. It's kind of obvious. Plot the points. Duh. Set of data is a table of x and y's, like we saw up here on the top. How did we make this scatter plot? We just plotted the points. That's what we're about to get some practice doing right now.